This is the first version of a landmark navigating robot that I made using the Takatsu framework and an iRobot Create. This version attempts to cluster what the camera sees into states using a modified k-means clustering algorithm. It then builds a directed graph of clustered states as nodes and actions as edges. Reinforcement learning is then used to adjust the weights depending on whether or not taking an action resulted in the expected state. With this graph generated, it should then be possible to use a path-finding algorithm to determine how to go from one state to another. However, the clustering turned out not to really work, as a new state was generated for almost every step, thereby leaving the robot stuck exploring as it can't determine a path. Here it can be seen that if this version does actually manage to see its target, it can get to it. I then created a second version that, instead of clustering of the visual input, makes graph using the three color flags as nodes and actions as edges. It then tries to come up with the best average path based upon the currently visible flags. Can also be seen here that the exploration algorithm has been changed to look around locally rather than go forward as the first one did, hopefully causing it to not drive past goals like it did previously. There are, however, some pitfalls that it can fall into, like getting stuck on walls, or its exploration algorithm can occasionally decide to explore one action considerably more than another for a period of time, though it would usually straighten out after a little while. It also has the possibility of getting close to a target, but being up against the wall so that it can't actually get to the target without hitting the wall. This causes it to learn that going in this direction is bad, so it eventually goes off in another direction for a little while. Another issue that can be seen is that even when it has a path to follow, finding an average or most probable path from a set of nodes to a single node allows for some varying, and it sometimes will bounce back and forth between going to the left and going to the right, going generally in the direction it needs to. Because it's seeing a slightly different set of flags each time. Even with these oddities, it does, in the end, learn the general direction it needs to go to get to its goal state. For example, this clip and the next one were several hundred iterations into the learning process, and it has learned to go in generally the correct direction to get to its goal.